Live from their home studios, please welcome the hosts of DevCentral Connects, John Wagnon and Jason Rahm.
Space, the final frontier. These are the live streams of the F5 DevCentral community, our ongoing mission to explore new ways to connect with all of you and to boldly go where no community has gone before. Ladies and gentlemen, this is DevCentral Connects. I'm John. This is Jason. We have a bit of dramatic music in the background. This is a special day, Jason. It's good to see you, my friend.
Thank you, sir. Yes, I am super excited about what we have in store. In fact, I'm as fanboying about this show as hopefully everybody who's joining us. So.
That's awesome. That's amazing, man. As am I. Hey, I've got a fancy new background here today. It's all the planets in our solar system. You know, shout out to maybe Pluto's out there somewhere. I don't know. Is that a planet or not? I don't know. We'll find out maybe today. But hey, today we're all about NASA and the Jet Propulsion Laboratory. So, Jason, it's going to be amazing, man.
It is, and nobody can see it, but I got my JPL shirt on today, representing. And
there it is.
I'm excited. Feel like I'm getting in the mood by, wearing, it's like, your game day on Sunday, you're wearing your NFL team jersey to get in the mood, and same deal here. So
it's the same kind of thing. Well, Jason, if I'm not mistaken, you don't have to look too far within your own family to find another fanboy. Is that right?
This is true. Yeah. My son is a big fan of all things space. Not just a few weeks ago, my 16-year-old set up an ISS and launch facility in the front rooms of our house. And that's, you see the space backdrop that he used. And, so yeah, that's my son Eli, and so we get a kick out of him. He's so excited about all things space, and really, I was a big fan of space when I was a kid. And you go through just growing up and getting busy and all that, but then he's so excited about space, it gets me excited about space. And you're speaking about all those planets there, and it blew my mind. I think I shared it as a trivia at the intro. Maybe it was to one of my You Want Answers, but it's like. Like a true or false. Can you fit, if you line up all the planets by diameter, do they fit between the Earth and the Moon? And on average, between their distance, because the Moon is not, completely equidistant depending on its rotation.
Right.
But
right.
if you take the average of its distance from the Earth, totally, all the planets can fit by a few thousand miles between the Earth and the Moon. Isn't that crazy?
The edge of
that
the Earth
blows my mind.
And the edge of the Moon. You could fit all, like Jupiter can fit in there, and Neptune and all that stuff. That's amazing. I did not realize that.
Yeah, because the volume of Jupiter, our largest planet, like the Earth can fit in like 1,000 Earths can fit in the Jupiter, and 1,000 Jupiters can fit in the Sun by volume.
That's amazing.
But when you look at diameter and stuff, it's slightly different story.
Anyway. Yeah, it's a little different. Yeah. All the math problems. And I tell you, man, today we're going to be talking to one of NASA's own Jet Propulsion Laboratory guys, Bill. And one of the things we'll talk about is, do you have to be a rocket scientist to work there? And maybe you do, maybe you don't. Maybe they got a lot of different opportunities, So Jason, maybe it's time to bring him on. What do you think?
Yes, I think we need to go there. So,
all righty, there he is.
Bill Dunford, JPL, thank you so much for joining us on this show. We are so stinking excited to talk about all things space. So, first off, tell us your story. Like, how did you get involved with the maybe space first, and then how did you get involved with JPL?
Well, like you and your son, I wanted to be an astronaut when I was 5, right? So I got to high school and was thinking I was going to be an astrophysicist, and then I discovered that I was not good at math. I have the mathematical ability basically of a houseplant. It's not pretty. So, but I found that I could write. So I kind of forgot about space for a while. And then as an adult, I discovered that the Voyager mission that we sent out beyond the solar system, in the 70s when I was a kid, was still active, and NASA was still talking to it every day. And then I found out that there were a lot of missions. We had missions at Mars and Saturn, robotic missions, not astronauts, but robots. And I was just fascinated by this. And NASA made the pictures that they took on a daily basis freely available on the internet. So I thought people should know about that. And I started this kind of little science education website called Writing with Robots on the High Frontier. And did that for a while, got into a podcast about it. Apple called me one day and said, "Hey, is this podcast kind of a permanent thing?" And I said, "Well, yeah, why?" He says, "Well, it's going to be on the homepage of the iTunes store tomorrow." I said, "Oh, okay." And it kind of took off from there. So I did that for a while. And then about 5 years ago, JPL, NASA's Jet Propulsion Laboratory, who manages a lot of these robotic missions for NASA, contacted me and said, "Hey, do you want to do what you're doing for this side project of yours for us?" I thought about that for about 8 milliseconds and said, yes, I would like to do that. And that's what I've been doing ever since. And I admit it, it's a sweet gig. It's a great job. I'm posting pictures about space every day. I don't have to do a lot of math, but I'm looking at planets and everything. And kind of maybe one highlight was we did this big package for the end of the Cassini mission to Saturn, which was a spectacular mission. And at the end of it, for a variety of reasons, to protect some of the moons of Saturn that might have had life on them, we intentionally scuttled the ship by putting it into Saturn, by crashing it into Saturn in 2017. Wow. And to explain why we were doing this and everything, we put together this package for online media. Social media and websites is a lot of what I do. And we had a team that made a video and put together this package. And we actually won an Emmy for it. So wow. I found myself in LA, holding an Emmy statue, and which was a surprise in my life, considering I don't, work in television, first of all. I have looks for backstage, I have a website admin looks rather than, but that's where I ended up. So it's been crazy and it's been fun.
Oh, that's amazing.
What is it? You're like 1/4 the way. What is it? Emmy, Tony, Oscar,
EGOT.
Golden Globe. So you're the EGOT. Yeah. So you're almost
the only one. We have a lot of videos and music and podcasts. The only one that worries me is the Tony. I don't see how we're going to get a stage play, a musical in there, but we'll see. You never know.
I've seen weirder ideas end up on Broadway.
So.
Yeah, that's right.
True.
Or Bill, instead of the EGOT, you'll just get the ego, which is well deserved, right? So
done. Too late.
Hey, really quick,
go ahead.
That's the stuff that you put together for the Saturn Cassini mission. Is that, I know you it's the video or the whole thing. Can people still watch that today? I'm fascinated.
Absolutely, yeah. It's not one of the links that we had talked about, but it's at solarsystem.nasa.gov/Cassini, and we can throw that up, or we can figure out a way to do that. Or just go to the solar system site that I'll be showing and just search for Cassini and Saturn. You'll find it.
I love it. Yeah. Must see TV, right, Bill?
Pretty cool, I think.
Love it. We have a question already. It's Chaz, it's like, why is it taking so long to put a base on the moon? It says, of course, I believe there's already a forward party on the surface.
That'd be news to me. Well, there is a forward party on the surface, and that's some of these robotic missions, which is what I work with. I'm not involved with the human program. In other words, astronauts. It's all robots, because the robots go not only where no one has been before, but where no one can go yet, like to Jupiter and landing on Mars and stuff. People may go there someday, but not yet. But right now there's a number of robotic missions landed on the moon. The Chinese have one. We don't have one right now, but in the next couple of years, we're launching one called Viper, which is an acronym I don't remember which stands for. We'll be searching out icy deposits at the south pole of the moon. And we, with our Artemis program, are planning to land people on the moon again. Right now, the target's 2024. I don't know if we'll make that, but that's happening. And that's supposed to be a sustained presence. The first party won't stay there, but that's going towards building moon bases. That's where we're headed right now. The reason it's taken so long is it's just not easy. It's very expensive, and it takes a lot of effort and political will to do that. And that's now happening again. Look at the NASA Artemis program. We're headed back with people to the moon.
Yeah,
nice.
Well, and I think it's a matter of priorities too, right? As we move into, kind of talking about the golden age of exploration here now, it's a matter of priority. For the longest time, it's like, well, we've been there, done that, and so we're moving on to other things like Mars and all that. But politically, as you mentioned, that became a bigger priority a few years ago. And to your point, it just takes time. It's not like, driving down the street to the Wendy's and, picking up a hamburger. There's a lot that goes into that.
Yeah, that's right.
Yeah. Hey, really quick, some of our crack researchers here on the DevCentral side found the acronym for VIPER. I believe it stands for Volatiles Investigating Polar Exploration Rover.
That's what we call a backronym. They take the acronym and make the words fit. That is true.
Yes.
Volatiles in this case refers to things like ice, water ice that can evaporate. And so yes, it'll be searching for ice deposits near the South Pole of the Moon, and that's where our astronauts are slated to land as well.
Yeah, I love that. And I love it too, where it's like, hey, NASA comes with an idea. The Viper just sounds so awesome. We must make it fit. We cannot find another acronym.
It happens sometimes. Yeah, I don't know what the story there. Yeah.
Yeah. I love
we also
it.
have NASA has an orbiter at the moon right now too, called the Lunar Reconnaissance Orbiter. It takes pictures so detailed of the surface that you can see the Apollo landing gear. You can see the footprints from the astronauts. So it's called Lunar Reconnaissance Orbiter, LRO. And it's doing this mapping in advance of these future landings.
Nice.
Yeah, if we can't convince people that the Earth is not flat, we probably aren't going to convince the people who say that we never landed on the moon either, even with those high-res images. So,
Right.
But that said, I want to see those high-res images. So that's we'll have to get that link out as well. The LRO for the moon. I'll have to check that out.
Right.
Yeah. Beautiful.
Okay. Well, you had some stuff to show us. You want to go through some visuals?
Yeah, absolutely. So can you all see my screen now?
We sure can.
Okay. So this is solarsystem.nasa.gov. I have a ton of URLs. I'm going to show a ton of URLs today. If you can't remember all of them, just come back here. This is a good place to find it. This is sort of your headquarters for robotic space exploration, what's going on right now. You can see the features up here, and then we've got the latest news, pictures, videos. If you want to know what's going on, this is sort of your headquarters. And then I also follow NASA Solar System on social too. Twitter and Facebook and Instagram. We're on all those. One of the fun ways to keep up with where the spacecraft are right now, what's going on in the solar system, is to click this little spinny solar system up here at the top. Click on that right there, and it's going to bring up Eyes on the Solar System, which is our 3D real-time solar system simulator. And you can do this on your browser or your phone. There's also a downloadable app that does even more features, but this right here in your browser will take you all over. This shows you the current positions in 3D of exactly where all of the bodies in the solar system are, and also where most of our spacecraft are. I'll just give you one example. So let's click on Jupiter. Gives you some information about the planet, and this link will take you out to all the details and more that you ever wanted. Click on Jupiter, and it's going to zoom us right into the planet. And that's exactly its configuration towards the sun and everything that's going on right now. So I'm going to zoom out again. You see there's an orbit path around Jupiter, and that's going to be our Juno mission, which is orbiting Jupiter right now, and it's taking me too long to scroll, but there it is. So this is the actual current position of Juno as it goes around the planet. It gives you some information about it. I'm going to click on that, and we're going to zoom in and see where Juno is right now. This is what Juno looks like. It's got these giant solar panels, and you can see where it is in relation to Jupiter right now and its moons. And this is an exciting mission. I'm going to show you a couple of other links about how to get the amazingly beautiful photographs from Juno. And this just tells you all about it, where it is exactly right now. And I can just go exploring from here. I can zoom into Europa. Europa is seriously cool because it's this kind of boring looking eggshell on the outside. It's got this icy surface. But underneath the ice of Europa, there's a liquid ocean, liquid water. Has more water in this ocean than all the oceans of Earth combined.
Wow.
And well, on Earth, anywhere there's water, anywhere in the bottom of a cave or a hot vent or the bottom of the ocean, anywhere there's water, there's life. Now, we don't know if there's life on Europa, but it's one of the promising places to look because of this water. And we've got a mission that's launching in a few years called Europa Clipper, and it's gonna actually orbit Jupiter, but make close passes by Europa, give super detailed pictures of the surface, and it has instruments, magnetometers, and other instruments that can help us find out, kind of peer inside, figure out how thick is that ice shell. Are there plumes of water that are coming through these cracks here? You know, what's the composition of that water in Europa? So this is a great little tool for just zooming around the solar system and seeing what's going on, where the spacecraft is. I can also, I'm not zooming very well today, but I can also go out here and I can go, there's the Voyager's way out there.
Wow.
And
I clicked on that one the other day and I was like, yeah, that's inactive. So for the ones that are inactive, does that mean there's just no mission associated to them, but you're still getting data? Or
no, Voyager is
not even getting
definitely
data
active
anymore?
Voyager is still alive, still taking data. Not all of its instruments work anymore, but we're still in contact with it every day. Voyager 1 and 2. They are now in interstellar space, and we're still getting information about the climate in the space between the stars from Voyager. And if you were riding along with Voyager, this is this is how far away it is. You can see the entire rest of the solar system just in one shot.
Wow. Hey, Bill, I'm seeing right there on the Voyager little details, it says September 1977, I believe. Is that when it launched?
Yeah, right here. That's right.
Yeah. Goodness.
Still
that's
going.
amazing.
You know, I think about the systems that we build today, and almost like commodity throwaway stuff. Like we build networks and we expect our routers to last 3 to 5 years, maybe our switches 5 to 7 years, that kind of thing. It's a whole different level of design process to build something that we can't just walk down the street and fix. And it's fascinating that something completely untouched has been mostly functional and returning data for, I'm not super great at math, is that 44 years at this
44
point?
years. Yep.
I mean, that is insanity. And
yeah. I think we've taken too much time
built it.
on this, but this is the famous golden record, which is a message to any aliens that may pick up the Voyager spacecraft one day.
Really?
So everybody go check that out. I think we've taken too much of the show on that, but
yeah.
Did
Man,
Bruce
really
Dickinson make that golden record? He might have.
One other real quick thing. I think I'll skip some of these in the sake of time, but another thing to check out. This is at eyes.nasa.gov. Hopefully, maybe we can throw that link up there. This is the second link. This is the DSN now. So NASA has these gigantic antennas in 3 locations around the globe to talk to these spacecraft. It takes hours for the light signal, as you were mentioning, to get out to Voyager, and these are the amazing antennas that do it. This shows in real time, live, which spacecraft we're talking to with which antenna at which download station. It tells you, how long it takes for the round trip light time for the radio signal to get there. And is this practical information for most people? Probably not, but it's cool.
I think it's cool. Yeah, I mean, you can see the range there for Voyager 1, a little over 23 billion kilometers. It takes almost two days for the light. I mean, the speed of light, right? It takes 2 days to get out there and back. I think that's it just shows you the distances that we're talking about. It's such a long way. It's crazy.
Yeah. Yep. Well, and the implications too, right? You think about hey, we have rovers on Mars. Can we drive those like RC cars? And the reality is we can't really do that because the time delay is so significant that you really just have to give it an instruction set, let it do its thing, then report back, then give it another instruction set. And but also even with the antenna thing, I think that goes to show you it's like there's a lot that goes into being able to communicate with far off devices. And Bill, in our pre-prod call, we talked about the James Webb satellite, or the James Webb telescope that's going to go out there in one of the Lagrange points. That one of the things that we can't do with Hubble is use it 24/7 because there's dark time, right, with the way it is around the Earth. But with James Webb, it's going to always be visible to the sun, and so it's always going to be powered and be able to be used. So that telescope's going to be able to be used 24/7 versus Hubble that can't be. And I think those kinds of things that go into design thought, and then implications if maybe we forgot about some design things, that the iterative process of making things better.
Okay, I won't spend any time on it, but here's yet another real-time site, and this is eyes on the Earth instead of eyes on the solar system. Most of NASA's mission are studying the home planet. So this site will let you see in real time, exactly what's going on and what missions are seeing, and what they're seeing in terms of CO2 and sea level. And this is our latest data from all of those satellites that are studying the Earth. So that's something that's important to check out as well.
That Jason 3 caught my eye. I'm going to have to check that out.
Yeah, for sure.
Of course.
And real quick, I wanted to ask a question about the like space garbage. You see in a lot of these Hollywood movies, whether it's WALL-E and the rocket blasting through pretty much a dump to get out into space, and then shows like Gravity where they're being torn to shreds, and even the ISS recently got hit by some space junk that did some damage. How big a problem is that?
It's definitely a real problem. It's a problem that has the potential to get worse as more and more satellites go up. It's something that the community is definitely looking at. They're definitely looking at different technologies. NASA, private industry is looking at different ways to bring these satellites down, to clean up that junk. What you see in the movies, you'll be happy to know, there was a huge exaggeration. You'll see diagrams where it looks like the Earth is completely surrounded by stuff. And I mean, it's there. But at that scale, each one of those dots is like the size of Paris, right? So they're not really that big. There's still tons of room. So it's both a serious problem, but not nearly maybe as immediately catastrophic as what you might see in a movie. Does that make sense?
Absolutely. Yep.
Yeah. I'm shocked that Hollywood would exaggerate, Bill.
Yeah, never. Especially in space movies, never.
This is news. Yeah.
Well,
that's crazy.
I could nerd out on this stuff all day long, but we're already, I can't believe it's already 7 minutes until we're closing up. So I wanted to get to, some of the things that, like, you started out, you weren't an employee, you were just an enthusiast and a passionate, space nerd, and that ended in employment for you. But it doesn't have to be, and you can still contribute to the overall goals for space exploration. Can you talk about that a little bit?
Yeah, there's a lot of ways to do that, and really quickly, I'll show you a few. If you go to our fourth link here, or I'm not sure the number, maybe this is the fourth link. Yeah, this is the feed of raw, unprocessed images that are coming from our latest Mars rover. This is the Perseverance rover, and it's exploring the surface of Mars right now. And you can see, this is an image that was taken yesterday. You can zoom in on those. This mission is actually taking samples of the surface that we're going to return to Earth someday. Here's a picture that came down yesterday showing inside one of the sample tubes to confirm that we got the sample. So you can go to that link, and there are several others like that. You can just search on the site for the latest images from the Mars rovers. And anybody can come in and process these, blow them up, stitch them together, make artistic things out of them. And that's one of the ways I got involved. So what I was doing on my Writing with Robots site was just taking my favorite image of the day that was coming down from Saturn or Mars or wherever, and I'd throw that up there. And that's what I did. And anybody is welcome to dig into those archives. Here's another example. There's that Juno mission to Juno. When the images come down raw from the spacecraft, they look sort of like this. You can kind of see that's Jupiter, but they're not prettified yet. Well, the community goes in, and what they do is they make something that looks like this out of it. This is really what Jupiter looks like, and the community has gone in and done that out of the raw data. So that's one way you can get involved, image processing, and that's kind of how I started, and that's a fun way to do it.
That's cool. Yeah, I also I listened to it was a Python podcast, but it was there is a I forget her name, but she works within I guess on her PhD she was working on machine learning of looking at deep space images and cataloging and all that, looking for anomalies in what they would expect in certain quadrants of deep space. And so different kind of image processing, but still image processing nonetheless.
That's right. Another way to get involved is I skipped ahead, but here is NASA has for all. I'm not a technologist, but I know a lot of you are, and there's lots of ways to get involved. These hackathons is one. The Space Apps Challenge has been very successful, and there happens to be one coming up right now. If you're seeing that. So I would check out spaceappschallenge.org and check out some of the projects that people have done in the past and some ways that you can get involved. This is all about solving real-world problems on Earth and using space technology to do that. And that's an exciting way to get involved. Got a lot of coders here, I'm sure. Code.nasa.gov. This is the agency's open source repository. Just tons of projects that have applications for all kinds of industries and useful stuff. That's a great way to get involved. They're trying some different experimental ways to do that. It has got a step-by-step process how to get involved with that. And finally, there's the whole aspect of citizen science. This is a really exciting field that's really exploding in the last few years. Not just space, as you can see, there's a lot of different ones, Earth-related, space-related. These are projects that are driven by actual scientists doing real science, where they ask for the public to get involved and take data or analyze data, process data. Here's that JunoCam processing that we were just talking about. Counting craters, scanning the raw data for comets, looking for asteroids, looking for exoplanets. You can do real science, get involved if you got some little bit of technical skill. Some of them require a little bit of technical know-how. Some require almost no technical know-how. But science.nasa.gov/citizen science. It's just a fantastic way to do, get really hands-on with this and apply your talents to driving all this forward.
Yeah, I tell you one quick thing I would mention on that is not only can you get involved with some super cool, science and NASA and space and all that, but we talk to people along the way that that are looking to break into like the coding, environment or the coding community, or get a job in that area. And they're like, man, how do I get experience with that? Because employers are looking for experience. And Bill, it seems to me this is a great way where scientists and, researchers are saying, we need the help. If you'll just help me, then you can really build some resume skills with this, right?
Yeah, I definitely would think so. It was kind of my entry, but we need all kinds of people at NASA. We need engineers and mathematicians and astronauts, but we need coders, IT admins, artists, lawyers. We need and have all of those things. If you go to the main NASA website, nasa.gov, just go to the careers section there, and there's all kinds of information about what kind of resume builders you'd be looking for and how to get involved. Internships, tons of internships at all different levels, from high school up to post grad. So there's so many entry windows in.
Yeah, I love it. I love it. Yeah, I was thinking somebody built that really cool website that's interactive about the solar system, and you click and it zooms in, and so all kinds of good opportunities.
Mm-hmm.
Yep.
Good deal.
Yep. Well, we are at time. I can't believe that we have to stop talking about space because I could go on for hours. But Bill, thank you so much for sharing your passion, and hopefully it's been just a great experience for you guys, the community, to see all the great tools that NASA's building for our pleasure, but also to stoke interest and reignite that golden age of space exploration. So, Bill, thank you so much for joining us.
Oh, it's my pleasure. As you can tell, I hate talking about space. So
I love it. Love what you do.
All right.
Awesome. Well, thanks so much, Bill.
Thank you. And hopefully we'll have you on again sometime.
Anytime.
All right.
All right. Take care.
Bye. All right.
Wow.
Yeah.
That was awesome.
Yeah. In fact, that first one he was doing is like, I was playing around with it, but I didn't know that I could go, in depth, even at the planet level. So I'm going to have to go out and play with that one again.
Yeah. Didn't know you could go that deep. Yeah. And I thought, man, that golden thing on the Voyager 1, satellite, that it's like, hey, if aliens ever see that, it's like the golden disc. And man, I didn't even know that thing was a thing. That's awesome though.
I know.
So I'm gonna have to dig into that. Like, what does it even say and all that? So, community, maybe you could comment on that. So
that's right. Yeah. And I have more questions. Like, most of that animation looked like it was fairly, it was all coplanar, and like everything's kind of in the same plane, but I think some of the planets are at like angles, but maybe not. So I'll have to go dig into that a little bit more to see if my assumptions are wrong or not.
Yeah. So very sophisticated. That's super cool.
Well, John, we have done DevCentral Connects a couple weeks in a row, but we have something a little different next week. Yeah.
Yep. We've got the security sidebar coming up, so it's going to be a lot of fun. Digital as default. So in the world where everything is going digital, then what does that mean related to security, and how does that open up security problems or solutions or whatever? So I'm going to be talking to the one and only Lori McVitie. So it's going to be a great conversation next week. So.
Absolutely. And then the week after that, we are back here, DevCentral Connects. Times they are a changing. We have some changes on the DevCentral team, and that's going to be exciting to talk about, as well as some other changes that might be coming up in the new fiscal year. So
that's right.
Join us for that. That's going to be a good conversation. And then we're going to close out the fiscal year with a talk with Vinny Matza and John Callalang on the F5 Digital Customer Engagement Center. They built a lab framework that allows you to take your lab experience, whether it's on your local laptop or out in AWS or Azure, wherever you want to do your lab, you'll be able to do that. And so, it's in its infancy, but it's going to be a great tool. So join us for that. It's going to be exciting.
Super cool. Hey, really quick before we get out of here, I want to highlight what Daniel Wolf just popped up in chat. He talked about the golden plate of Voyager 1. And so maybe we could pull that up really quick. He says it's got some pictogram of our solar system, male, female, binary, something, if I remember. Really interesting. So maybe we can dig into that. It's piqued my interest. It's like, what does it mean? If I was an alien, I don't know. So super cool. All right. Well, I didn't mean to sidestep, the upcoming shows, but great comment there, Daniel Wolf. Always good to see you, my friend. So good deal.
Absolutely. Well, John, we are at the end of another show. Audience, if you like content like this, give us a thumbs up. If you thought we were terrible, give us a thumbs down. But of course, we're not terrible, so thumbs up. Right?
How could we possibly be terrible? That's right.
And make sure you click subscribe if you like content like this. So thank you so much for joining us. Make sure that you have a fantastic weekend after you get through the rest of today and tomorrow.
That's right. And we'll see you next week.